a case study on United Flight 232. In this video, I will be discussing how it happened, why it happened, what allowed it to happen, and some extra helpful information in the video, such as how it could have been prevented so that it can't happen again, and what can we do to make sure that it doesn't happen again. The flight crew consisted of a captain, first officer, and a second officer with 8 flight attendants. Captain Alfred Hayes, First Officer William R. Records, Second Officer Dudley J. Dvorak, and there was also a training check airman, Dennis E. Fitch, with another 285 regular passengers on board, making the total amount of people on the flight 296 people. The aircraft in the accident was a McDonnell Douglas DC-10, delivered in 1971. The aircraft had a total of 43,301 total flight hours, with 16,997 total cycles of pressurization. Before the flight, the cabin staff reported a minor electrical fault in the galley, but the engineers gave it the all-clear to continue on with the flight to Philadelphia. On July 19, 1989, the DC-10 United Flight 232 departed for the first leg of the trip to Chicago. No issues reported. At 3:16 p.m., a loud boom was heard throughout the aircraft. Some of the passengers thought a bomb went off, but that was not the case. Up in the cockpit, the captain of the aircraft, Captain Alfred Haynes, noticed that the tail-mounted number 2 engine showed indications of malfunction, so he followed the appropriate checklist and shut down the number 2 engine. Soon after Captain Alfred Haynes shut down the engine, the second officer and flight engineer, Dudley J. Dvorak, noticed that they had lost all hydraulic pressure in all 3 systems. At the report of this, both the captain and first officer tried to manipulate the flight controls. With the aircraft no longer responding to the air control inputs, the plane was no longer controllable by conventional means. With the loss of hydraulic pressure in all 3 systems, the plane was only controllable by altering how much thrust the remaining engines were putting out to turn the plane. A little later, a DC-10 training pilot that was also aboard the flight, Captain Dennis E. Fitch, was informed of the situation and offered up his assistance. At the request of the captain, he was asked to visually inspect the wings and report any issues. At 3:20 p.m., the crew contacted Minneapolis Air Route Traffic Control Center and declared an emergency, and vectors to the nearest airport for an emergency landing. At first, the controller suggested Des Moines International Airport, but sometime later they suggested Sioux Gateway Airport for the landing, as they were already heading in that direction. The captain responded with affirmative. When the flight crew started to make their way to Sioux Gateway Airport, the second officer of the plane, Dudley Joseph Dvorak, was sent to inspect the empennage and reported damage of the rudder of the aircraft. As the aircraft was descending, the pilot in command jettisoned fuel to the automatic system cutoff, which was 33,500 pounds, and lowered the landing gear to prepare for the landing. At 4 p.m. and 16 seconds, the DC-10 crash lands at Sioux Gateway Airport. The right wing and engine touch down first and the aircraft hits the ground. The plane begins to screech as it slides down the runway, and a fire starts as the different sections of the plane starts to break up and continue to skid across different parts of the runway and airport. The aircraft split into 3 main sections: the cockpit, tail, and middle passenger sections. In the end of it all, 112 people lost their lives due to the crash. The NTSB got to the scene of the crash after 9 hours. When they got there, the first priority of their group was to find out what happened by putting the plane back together, because with the plane back in one piece for the most part, they could identify what went wrong and where. As they pieced the plane back together, they get some new crucial information. About 56 miles away from Sioux Gateway Airport, some aircraft wreckage was reported, and when investigators arrived at the scene, they realized that the wreckage found include parts from the hydraulic section near the tail of the number 2 engine. With this new information, the NTSB investigators analyzed the flight path of the aircraft with timestamps and realized that at the time of the explosion at 3:16, and with the distance related to the airport itself, that the both were linked, that this event happened because something happened with the number 2 engine. With a new lead, the investigators focused more around the number 2 engine and realized that there are puncture holes in the hydraulic lines of all three systems. That all happened at the same time. Investigators examined the puncture holes of the lines and find minute traces of titanium in the holes. The only place near this area where titanium could be found is inside the number 2 engine of the plane. When the team starts to reconstruct the number 2 engine, they realize their final clue, that the engine fan disc, made out of titanium, was missing, and now it all came together. The investigators now know how the crash happened. They know it was a fan disc fracture, but the investigators still don't know why the fan disc fractured in the first place. The fan disc has to be found and examined before more planes, with potentially the same issues, go down. The fan disc was located and examined. After the testing, it was found that the fan disc was given an excess amount of nitrogen when the disc was being forged, and it was that excess amount of nitrogen that caused the impurity that then turned into a crack that then caused the disaster to happen in the first place.
The faulty fan disc can no longer cope with the stresses imposed.
The NTSB found that the fan disc last had maintenance 16 months before the accident and concluded that the crack was of detectable size, but just wasn't found and missed due to human error. The NTSB cited human factors as an industry-wide problem. In wake of this, the FAA, the Federal Aviation Administration, upgraded maintenance standards for engine checks to prevent events like this from happening again. The FAA also made airlines upgrade existing DC-10s to have shutdown valves in the hydraulic systems to avoid further hydraulic fluid loss if something similar happened again. I interviewed Rahula. I asked him, what would you have done to prevent the situation? His response being, I would run more frequent D-checks on the aircraft for inspection as the aircraft as a whole. He would run through each plane to make sure everything was working as it should be. Another question I asked him is if he had any other recommendations. He said that he would remove the engine and do NDT testing, non-destructive testing on the engine, to see if anything was wrong with it. My last question to Rahula was, what's anything else that you would do? His reply being that he would run inspections every 100 hours of flight and test the crucial parts of the aircraft for anything wrong. Since this accident was caused by lack of attention during maintenance, like the NTSB, the FAA, and Rahula, my view on the matter is that it could have been easily been prevented by more rigorous maintenance checks, and to have more fail-safe functions on the aircraft to mitigate damage and to stop more things from going wrong as a whole on the flight. Thank you for watching.